threads are, so basically threads are nothing but they are it's a mechanism such that we can do multiple tasks concurrently. Okay. Here a single process can have a multiple threads. Single process, we can write different functions in a single process, and rather than writing normal functions, if we use threads to write those functions, we will be able to execute that functions concurrently. Okay, and moreover, these threads are completely independent. They are executing independently, but they all share the same global memory and BSS as well as your data sections and heap sections also.
Okay.
But then you have here, if at all, if one thread is blocked, then still others will execute. So it will not just interrupt the other thread. Now we do have some limitations. First, what it is process. Okay, what is that process? Already we discussed it. There is some limitation for process yesterday, and what is that limitation was to share information, because it is very difficult to share the information between the process. If we want to share the information between the process, we need to use some IPC mechanism, inter-process communication. Okay. But when you use threads, we need not do that. And process creation with Coke is relatively expensive. Why it is expensive is because here it is sharing so many things. When you are using threads, you are sharing so many things. But when you are creating this using a Coke, so that means you are creating one more process. It will have to copy the whole thing again. PCB, everything has to be copied again. So it is relatively expensive than compared to thread. So how thread is executing, how thread is making a way to solve these problems. Now, sharing the threads between it is easy. Why it is easy is just because so whatever data has to be shared, it is either sharing it in as a global variable or heap variables in shared data memory. Okay. Now here we will have some problem here. If at all, if some as the shared, it is easy to access the memories, or I mean easy to access the information. So maybe 2 or 3 threads may try to have same thread. They may try to access the same variable. So at that time we have to take care. That is one limitation, but that can be solved using the techniques. And the thread creation is faster. Almost it is 10 times faster. And it uses clone system call to create the threads. And clone internally uses sys_clone. Already we discussed this yesterday. It uses sys_clone. Now, what are the attributes which are shared by threads? So threads share same attributes as PID, PPID, then controlling terminal. Some of these you know, and some of these we will see later. But the things which you know, I am just saying that. Then you have process credentials, user and group IDs. Then file disposition we have not seen. Current working directory, root directory, timers, semaphores we have not done. Resource limits. All these attributes are shared by threads. CPU time consumption, which is context switching, which comes along with context switching. Resources consumed, and this we have not seen. Set priority and nice value, we will see that later. So these are the attributes which are shared by threads. So if you have so many threads, then also all these will have common attributes, and these are the common attributes. So what does the attributes which are different, which are not shared by each thread ID? thread ID is unique for each and every thread. Similarly, signal mask thread specific data. If that data has to be specific only for that particular thread, that can also be created. Then error number and floating point environment, all these things I think we have not done. So stack is also different. Okay, yesterday we have seen that it will create stack memory for different threads. Stack one, thread function, stack for thread function 1, thread function 2. So it will create different stacks. Like we are creating it for functions, here also it will create stack memory for each thread.
Yeah.
Heap memory is shared, but stack memory is different. So these are the attributes which are distinct. So here right now we are going to use this thread ID because we are using thread in the following program. So thread ID will be using, and other than that right now we are not using anything other than stack. So first as well as last we will be using now. So here whenever we want to create some program here, we have to use some data types related to pthreads. Pthreads is a POSIX library function, library call. So here we need to use some data types related to that. So here when you want to create a thread identifier, we have to use pthread underscore t. If we are using mutex underscore t, mutex attribute, condition variable, pthread underscore condition underscore t. Condition variable attribute, key for thread specific data, one-time initialization control, thread attributes object. We'll be seeing these things now. So these are the particular data types related to particular functions. Okay. Now here let's see this. Okay, we have said that error number. Now what is this error number? Actually what happens is we have different number of errors. Okay, and what is that specific error can be known by that particular error number. It is a global integer variable. Okay, now if we have this global variable, it has a global variable, and if I have some 10 threads running at a time, at that time, if at all, if some particular thread gives and returns an error number, so that could be confusing. That how we should know that which thread had made that particular error, has returned that error number. Okay, why? Because we are sharing a global integer variable. ERR error number is a global integer variable. So what happens if some particular thread is sending, it would be very confusing. So, and that's why here each thread has its own error value to remove this particular confusion. So each thread will have one error value, and there is no confusion. Okay, error number is nothing but a macro.
Yep.
And the value is modifiable, and that is available in one header file called errno.h, and it enables the implementation of a per thread error number. So each thread will have a particular error number.
Yep.
Error number variable, actually, not error number, it's error number variable. So what are the written values of pthread function? Generally, when we are creating any function, we will have some written values. So here the written values, whenever we are creating a pthread functions, or we are using pthread functions, not creating is also one function. So whenever we are using some pthread functions, it will return 0 on success and a positive value on failure. That positive value is nothing but an error number here. Okay, what is that error as well as that positive? Sometimes what happens, they give -1 as negative value if the system is failure. Okay, if failure occurs, the value will be negative. So here it is not negative, but here it is a positive value, and that value is nothing but the error number which we discussed previously. So that we can find out that exactly what the error is.
No.
Now, how to compile this? Yesterday we have seen that along with GCC we need to have hyphen pthread also given along with the GCC. Okay, only GCC particular file.c will not work. We have to use this pthread also. Now, if we use this, then some functions or macros are defined in the preprocessor reentrant will be exposed, as well as the pthread library will be linked in our program. Then how to create a thread? So when we are starting to create a thread here, okay, by default we have one thread in our program, and that is main thread or initial thread, and whatever then you write all are your subthreads. So one thread, main thread is one thread. Other than that, you are creating some new threads along with that, not subthreads, but these are all different threads. So here pthread create function creates a new thread, and that is included in header file called pthread.h. So here it takes 4 arguments. One is your thread ID. First one is your thread ID. pthread_t is of type pthread ID. It is pointing to that particular ID. Then you have particular thread. Then you have pthread attributes_t. Generally, if you are not using, yesterday we said that we have some flags if we are not using it. So particular attributes are there related, or that flags are there related to pthread. We will see that. So these, if we are not using, then we will have to set it to null. And then the pointer which is pointing to our function, and the arguments if we are passing something. If we are not passing something, anything into our function, then null. If you remember, we have something like we are starting, if we want to execute a program, argc, argb we were giving, we were passing. So here also, if we want to pass something, here we can mention it in double quotes. If we don't want to pass anything to our function, then we can simply write it as null. So second as well as fourth argument can be made null. If you use the second argument null, then it will take default values of that particular attribute. So first one is unique for all, and the third one is your function name. Okay, it returns 0 on success. Now here you have even termination also. So how to terminate a thread? So here we can use this, the following ways to terminate a thread. Now so if at all, if the thread itself gives you a return value, okay, or the thread calls pthread exit function. So here we have one more function called pthread exit. So with this also the thread can be terminated, or we use pthread cancel to cancel the thread, or if at all, if some particular main function is using return function, at that time it causes all the threads to exit, and pthread exit function also terminates the thread. Already we have written it here, pthread exit. Okay, and the here you have the syntax for this, which is pthread exit and a return value. Okay, so pthread exit function terminates the calling thread and specifies the return value. So here when you are using pthread exit, and it will return a return value which is obtained in another thread by pthread join. So here you are using two threads. One is pthread exit and the pthread join. So if you use this pthread exit, it will return a value which is obtained or which will be received by pthread join, and the thread will terminate. That's why we have here return value. So this return value is received by pthread join. These are the ways to terminate a thread. Now, thread IDs. So here we have unique ID for each and every thread. So when we are creating this pthread create, this is the first argument which we have. Okay, and if a thread wants to find out or obtain its own ID, then it can use one function called pthread underscore t. Pthread underscore self. Self is the function to obtain its own ID. Okay, and it doesn't give return because it is returning thread ID, which is a unique to all the threads. So by using this pthread self, we can find out what is the ID of the thread created, and it's unique for all the threads. So we have one more function called pthread equal. So it compares the two threads whether they are equal or not. So simply it will take two arguments. So here if this IDs, these are the IDs T1 and T2. If you compare just pthread underscore equal, pass these two IDs. If it is equal, it will return non-zero values. If it is not equal, then it will return 0. Returns non-zero if both are equal. Otherwise, so what it will return actually, it will return your ID because both are equal. So it doesn't have any problem to return which value has to be written. So if both the thread IDs are equal, it will return that return value. If not, it will return 0. Pthread equal. Now here we have one more function which we used yesterday, pthread join function. So here this particular function will wait for the thread to terminate. That means once it finishes and terminates, here this is like a blocking call. Like in process we have something like wait call or scanf call, or one more we used, wait, scanf, and one more we used, right? Blocking call. One was wait, scanf, and we used in process as a blocking call. I forgot. 3 blocking calls we used in process. Okay. So here I'll just recollect it and I'll say what we have. Otherwise, we have it in our recording. So there, like we used some wait call. Here we are using pthread join function for the same thing. Now, if at all, if the thread is already terminated, then it returns immediately. So waiting for the thread to terminate and waiting, this we call this operation is called joining. So that's why it is pthread join. So here the syntax for this is pthread underscore t, which is nothing but your thread ID, and this is your return value. Return 0 on success, positive number or error number on error. So here we have one more thing called detaching a thread. So detaching a thread is something like you can say in easy terms like removing a thread from your main function. Okay, so here while executing, or you can say that if at all, if all the threads are running concurrently. So if we want to stop the execution of that, so we can detach it from our running list. So that we use a function called pthread detach, and we are giving simply one argument, and that is pthread ID, which is an ID. Okay, it returns 0 on success and positive number on errors.
Yes.
Now, thread versus process. Here, advantage of this multi-threaded approach is sharing the data between the threads are easy, and sharing the data between processes is difficult. Why I am repeating this again and again is because this is asked in interviews, that what is the difference between thread as well as process. Okay, in a process we will have so many threads, or else we can say that by default a main program will have at least one thread, and that is main thread. So sharing the data between the threads is easy, but sharing the data between processes, it requires something like IPC mechanism. And thread creation is faster than process creation. And if the context switch time is less per thread than per process. Yesterday we have seen context switching, right? So moving from one process to another process for a particular amount of time is your context switching. So that time is less per thread than per process. So the disadvantages we have per thread are we have to use threads very safely. Okay. What safety is required is for the variables which are being used. Okay, so if we are sharing some variable, we have to make sure that if at all, if one variable is, one thread is using it, the other thread should not use it at that time itself. Now if I am using some function, global variable, and if I try to change the value of that variable, two threads try to change the value of that variable concurrently, there will be an error. I don't know what type of error we may get. So that we have to make sure that the functions are thread safe. And if there is one bug in a thread, then it can damage all the threads. Okay, why it will damage is because they share so many attributes. So one bug will have so many errors. If we say process, all are isolated. All PCBs are different, right? For each process there is different PCB, for child as well as for parent also. Now here we have some particular finite virtual space for the processor, right? Now when we are using process, what happens? It is creating some virtual memory for process, right? But here what will happen? We have some finite virtual space for a process which contains threads. It is sharing the same thing, right? So here each thread will, if they have some thread specific data which is used only for that particular thread at that time, it consumes a part of it. Okay, and if at all, if it is using that particular part for this thread specific data, that space is not available for other threads also. Okay, so it may have some memory issues. Okay, if we are implementing large number of threads, because if large number of threads are created, more memory is required. But when we say process, it can have different virtual memory. Child will have different memory, virtual memory, as well as yes, parents will have. So if we want to select our choice, that whether we have to go with process or thread. Then here we have, first of all, it has to be very, very careful if we are using thread, multi-threaded system. Okay. Then in a multi-threaded application, what will have, the same program will run, but in same program, different functions are running, right? Only one process. Here, one application is nothing but that is also a process. So that process is running, but along with that process, different functions are running. All the functions in a process are running concurrently, right? But if we are using multi-process application, different processes can run on different programs. Okay, and then here we have so if we want our working directory, file descriptors, signal dispositions, all these threads also share all these informations. Okay, we have some attributes which are shared by your threads. So this may be an advantage or disadvantage depending on our application. So we can select whether we want to go with threads or process. If we don't want to share, we have to go with process. If we have no problem sharing the information, then we can go with threads. Now, here we have for thread synchronization, we are using two tools. One is mutex, and the other is condition variable. So what is this mutex? So here it is something like, in simple words, what it is when you are trying to access a variable, when one thread wants to access a variable, so if we use this mutex, it will lock that variable for that particular thread. Okay, such that no other threads should be able to use that until we unlock that. Okay, because the key is with you. Okay, so before using a shared global variable or any variable, if at all, if data sharing has to be done, so here what it is doing, whatever variable you want to, or whatever resource you want to share, so before using that, and now if two threads are there, thread 1 and thread 2, so thread 1 want to access a variable called something variable only. So thread 1 want to access a variable and thread 2 want to access a variable. Now these two will compete. So what it is doing, we are using mutex here. So mutex, what it will do, if at all it is assigned that okay, thread 1 will use this variable, at that time first mutex is implemented. Mutex will lock that variable. Now the key is with thread 1. So till when it is using, thread 2 can't use it. Why? Because key is not there with thread 2. Once thread 1 finishes, it will unlock that variable, and then thread 2 will be able to use it. So it is simply a locking mechanism, you can say, in simple words. Mutex is a locking mechanism. And we have one more tool called condition variable. So here they allow the threads. Here the threads are informed about the other shared variables. We will see this. So they allow the threads to inform each other. So if at all, if some action has to be taken on some one thread, then thread 1 will inform thread 2 that take some action on that particular variable. So here this shared variable will, this condition variable will inform other threads about the action to be taken. Now coming to mutex. So we have to take care that if at all if we are using a multi-threaded system, at that time same variable at same time should not be modified, or all the threads or some same threads should not attempt to modify the same variable at same time, right? So if I am trying to read or write on that variable, so other threads should not use it. Now here comes one more term called critical section. What is this critical section is, in your code, the particular section where a shared resources is used, we have some particular thread, right? So there we are trying to access a shared resource, and when we are using it, that should not be interrupted by some other thread. So that particular section of code is called critical section. Why? Because we are trying to access a shared resource that can be accessible by all the threads. Okay, it is simply a section of code, that's it, where we are trying to access a shared variable. The shared variable can be used by any number of threads. But in our function, we are calling that, when we are calling that particular code, we call it as critical section, because we are using some critical information that can be used by some other threads also. Okay, and it should not be interrupted by any thread simultaneously. Why? Because it is a shared resource.
Okay.
So for that reason, we are using mutex. Mutex is a short form for mutual exclusion. So here it just ensure that only one thread uses the access the particular shared variable. Now in mutex also we have two states. One is locked, as I said you. First mutex will lock, and then that variable is used, and then it has to unlock. So mutex has two states. One is locked as well as unlocked. And the key for that particular, or the lock, or only one thread can hold the lock of mutex. Okay, multiple threads may not be able to hold the lock of it. So only one particular thread will be able to use this lock. Okay, and once a thread is locked, then that particular thread is the owner of that mutex. Okay, and whoever is the owner can only unlock the mutex, because the key is with that owner only. Okay, if we say one simple example, we have our homes, right? So we have the whole access on our home. So if we lock that only, then no one will be able to use it. We also can use it only after it is unlocked, right? So first lock, use, unlock. That's it. And it's not necessary that it has to be used on particular shared resource. We can have mutex for multiple resources. For different mutexes can be employed for different resources. So if we have something like 10 variables to be accessed, shared, which is sharing information, we can have 10 mutex also. So here is the mechanism they use. Lock the mutex for the shared resource, access it, and unlock it. Now in this again we have two mutexes. One is statically allocated mutex and dynamically allocated mutex. Okay, so mutex variable, which is actually mutex is nothing but a variable. So here mutex can either be allocated as a static variable or it can be created as dynamically at runtime. So if it is a static variable, it uses something like pthread underscore mutex underscore t is the data type. And whenever we are using mutex, always it has to be initialized. Otherwise, it will have a garbage value. So always initialize it. So when we want to statically allocate mutex, here it can be done like pthread mutex underscore t is the data type. So we are taking one variable called mtx, which is mutex. It is equal to, here is the value pthread underscore mutex underscore initializer, which is an initial value. So this is the this is one of the example we can initialize the statically allocated mutex. So after initialization, which is here declaration as well as initialization, here we write like int t equal to 0. So here this is initialization as well as declaration. After declaration, then the after initialization a mutex is unlocked. To lock and unlock we use two functions again. One is pthread mutex lock and the other is mutex unlock. These are the two functions which are used to lock and unlock a mutex. So the keyword for that is pthread underscore mutex. It's a pointer. Pthread mutex underscore t is the data type. Okay, lock and unlock. Both written 0 on success and error number if at all, if any error is there. Now, again mutex lock will have two variants. We were using mutex lock as well as unlock two functions. In lock again we have two functions which is variants are present, which is pthread mutex try lock and timed lock. Okay, try lock is almost the same as mutex lock only, but if the mutex is if at all if the mutex is already locked at that time, mutex try lock fails. Okay, this is same, try lock as well as lock are same, but if we are using an already that is locked, we will get fail as return value. Then here timed lock is also same as lock only, but here we can just have some additional arguments in this, which is time. So that time is nothing but a time limit where the thread will sleep till the particular time described, and then it will try to acquire the mutex after that particular time. So if I say 10 seconds, after 10 seconds it will try to acquire the lock. So here the time interval is specified in timed lock.
Okay.
Now, if at all, if a thread is already logged and the same thread again tries to log that, already it is logged. Okay. And again it is trying to lock it, at that time it will result into deadlock. Okay. If more than one thread is locking the same set of mutexes, then this deadlock situation occurs. It can be same thread or different thread. If it is trying to access, if it is trying to lock the already logged mutex, then it will result into deadlock. Coming to dynamically initialized mutex, here so for initializing the statically initialized mutex, we were using pthread mutex initializer, but here we are using dynamically initialized mutex using one function called pthread mutex init. So it will take around 2 arguments. One is your pthread underscore mutex underscore t, and the other one is the attributes which are to be passed to the mutex. We will see that while allocating it, and it returns 0 on success. Now, if where we can use this dynamically allocated mutex, if the mutex has to be allocated on heap section of memory, by default mutex is an automatic variable which is allocated on the stack, because all the automatic variable by default, if we are not writing anything, if we are not specifying whether what type of variable, like we can say auto storage, if we are not specifying the storage class of the variable, it will be by default automatic variable. So mutex is also an automatic variable allocated on the stack, but if we want it on the heap section, then we will have to use this dynamically allocated mutex. And when we are using this dynamically allocated mutex, then when it is not required, we have to destroy it. Okay, why? Because the space is utilized. So we have to destroy that such that that space can be used for some other variable. So the function to use this is pthread mutex destroy, and it takes only the mutex which we have used. Now, some mutex types are there. So pthread mutex normal, error check, recursive. A single thread will not be able to lock the mutex 2 times. Okay. And if at all, if a thread doesn't lock a mutex, then that thread, I mean the owner of the thread, will only be able to unlock it. The other thread which doesn't hold the lock will not be able to unlock it. Coming to your condition variable, now, so condition variable, what it will do is, it will allow the one thread to inform all other threads about the changes in the state of a shared variable, or it will wait for the thread for such notification. Actually here, if you have so many multiple threads, then one thread will inform the state of that particular variable to all the other threads. And always this thread condition variable is always used along with the mutex. So basically it is just monitoring the state. If at all, if the condition has met, then that particular thread has to work, and that information or that action has to be taken on that variable, and that is informed by some other thread. This might be somewhat confusing, but while writing program, it will be easy for you. So the here it can be initialized as it's a variable. So the data type is nothing but pthread underscore condition underscore t, and this is the name of the variable, and we are initializing it with pthread condition initializers, initial value. So basically it uses two operations. One is signal and the other is wait. Okay, this condition variable uses two operations. One is signal and the other is wait. So the signal we have two signal functions again for this. The one function is pthread condition signal and the other is condition broadcast. Okay, now both uses this condition variable specified by condition. Now broadcast and this signal will say the specify thread to take the action. But if we say broadcast, it will just make alive all the threads because it's broadcasting. Generally what happens, broadcasting is nothing but informing all. Okay, information will be given to all. So using this broadcast, all the threads can be alive. The signals can be sent to all the threads. But when you use pthread condition signal, it will be just informing one particular thread. And we have one more function called pthread condition wait. So it blocks the thread until the condition variable is signaled. So here are the three syntax for this: signal, broadcast, and wait. Here it takes only two variables, and that is your conditional variable address, it's a pointer, and next here it takes two. One is the condition variable and the other is mutex, and all returns 0. Here we already discussed this. So this is the initial functions for dynamically initialized variable pthread condition init, and the syntax for this is the pthread condition variable and attributes. And the destroy already we have seen. Now thread safety. Thread safety is already I said you that if a thread can be invoked by multiple threads at the same time, at that time we call it as thread safe. Or if one thread is not able to call another thread, then we say that that particular function is not thread safe. Okay, so what is the reason we will not have a thread safety? The most reasons are like global or static variables. Okay, why? Because multiple threads will try to access the same variable. So if we are not using any locking mechanisms, or we can say conditional variables or locking mechanisms, then that threads are not safe, because they all will try to access the variables they all will try to access the shared variables, and which might not give us the correct output. So one way is to use this mutex function. So we have one more function called pthread cancel. So here it will send the request to the specified thread to cancel that particular thread. So simply the ID will be given for this pthread cancel, that which thread has to be cancelled. On success it will return 0. Here there are two things in cancellation. One is the state and the other is type. So thread and type function are pthread set cancel state and set cancel type. So when we are using these functions, it allows the thread to control how it responds to the cancellation. Because once we send the request of cancellation, that will also send us a response. So that response is given by these two functions, set cancel state as well as set cancel type. So if cancel state is set to disabled. Okay. So if it is disabled, that you cannot cancel it, at that time that cancellation request is pending, because we have just disabled the cancellation request. If cancellation is enabled, at that time thread reacts to the target request that yes, a cancellation request has been made and it can be cancelled. So this was all about your threads. So threads and mutex and condition variables. I have just So here we are taking these two threads, thread 1 and thread 2. Here it contains the ID of the thread, and then fourth argument we are passing it like thread 1 and thread 2 as the message, and we are taking two more variables to store the return value of after creating the pthread. So pthread create, store the value here, and this is the ID. Then we are not passing any attributes here, so null. Print message function is the name of the function which we are making, like work as a thread. We can give any name to the thread function, and then the last one is your message, which is thread 1. So we are passing the address of it, void pointer message 1. Similarly, we are using it for thread 2. Now, after creating, what we are doing, wait till the thread terminate. So for that, what we are doing, wait. Blocking call we use here is pthread join, which thread 1, and we are not passing any attributes here, so that's why null. Similarly, again pthread join thread 2. So it has to wait for both the threads to complete the execution or wait for the termination of that particular thread. And after that, it is printing thread 1 return and thread 2 return with the return value. Now, what print message function, what does it contain? Char pointer message. So here the message is nothing but thread 1 and thread 2. Right? Print it. This is your thread. Now, two threads will execute independently. One is thread 1, thread 2. So continuously we'll get that particular output. You can understand it while writing. If you are having confusion, then I'll just write those programs. While writing program, I'll explain you. Because right now, those programs are not written in Ubuntu, and it's difficult for me to, or if you have time, I'll just write it down now itself. One program already I was writing. Just a second. Till now, is it clear?
Yes, yes.
So here, the first program which I explained, we created a thread. We are simply saying thread created, and then we are printing two threads. One is main thread and the other is thread function. We will execute this thread 2.c. Let execute it dot slash a dot out. see, it is running continuously and we don't even know that whether it is executing main thread function or here it is executing both the functions. Either it is executing this thread function or main thread. Okay, but it is executing both. It is not specified which thread will execute first, which is main thread or thread function, but it will execute both.
Hello.
Okay. I'll do one thing, I'll just write these programs or I'll just try to copy this from this PDF too, because I will have to share this folder again. I'll do that, I'll copy those programs and I'll explain you tomorrow, because without just explaining theory might be again confusing for you.
Yes.
Anyway, I'll not be able to execute these programs now. So I'll just copy these programs in Ubuntu and I'll execute it tomorrow. Okay, and if you have any doubts, you say me. I'll just mail this PDF to you on your mail ID.
Yeah.
Okay, and I have taken this from this textbook only, which I specified, Michael Kerris, Linux Programming Interface by Michael Kerris. So I have taken it from there only.
No.
So I'll just mail you this. Okay. So tomorrow we will see, mostly we will see. For process also, I'll just create this, like this one presentation or notes, and I'll send you.
Okay.
Okay. If you have any doubts, you ask me tomorrow. I'll just execute this by copying it. Right?
Yes. Yes, that's it.
Oh.
Okay.
Okay. Bye.
Yeah.